Hello Internet. In this video I want to show you a few cool things you can do on the command line. Now I'm going to be using bash, but I suppose you can do many of these on different shells. I do however recommend you do this on a Unix based system, not on like Windows, and we'll come to why that is in like a few minutes. So let's get started. The first one doesn't really count because I think everyone should know this, but I have come across a surprisingly large number of people who don't know this. So the very first one is that you can look at the documentation of any command by simply typing man and then the name of the command. So for example, if you want the documentation of grep, we can get it like this. And you can do basic stuff like searching by typing a / and let's just look for case because of case sensitivity, and we can find this. We can press N to go to the next one and capital N, so Shift plus N to go to the previous one. We can go like P to go to the top and basic stuff like that. But basically any good text editor has this already integrated. So if we like open up Emacs, and let's just go like this, and we can type meta_x_man, then type grep, and we get the exact same thing. We get the man page, and of course we can like search and use all the power of the text editor because this neatly integrates in a lot of text editors. Okay, so now let's go to the first one that actually counts. This is going to be this syntax. You have a command 1 here, and then you have a pointy bracket like an opening tag bracket. Then you have parentheses and a different command in here. Let's just call this command 2. So what this does is it executes command 2, saves its output to a temporary file visible only to command 1. So this isn't stored on your hard disk or anything. And then feeds the path to this temporary file as the first parameter to command 1. And you of course can do this multiple times. Always in the syntax you can add like actually existing files, like files that actually exist on your hard drive to this, no problem. So let's go to an application of this. Let's say you got two different files. I'll just open them up here. They are on my desktop and called file1. Let's open desktop file 2, and what this is just checksums. These are MD5 checksums of archives created by the Kiwix project. And let's suppose you downloaded the files on the right hand side and computed their checksums, and these are your results. And the ones on the left are all the available checksums of all the files that Kiwix provides, or any other checksums, or any other like file of which you have a part and you want to check whether this part is actually part of the original file. But these can be scattered all across this file. So if they were all in one block, comparing them wouldn't be a problem because you could just copy them and search for them in any text editor. But if these lines are scattered all across the file, possibly in different order, this approach won't work because you'd have to copy any single one of these lines, and of course these can be thousands of lines for many different files, and you don't want to do this. So what you can do is simply open up terminal and then issue this command. We do a comparison, and these are just ignoring certain columns. And we go sort file1 and sort file2, and this will automatically alphabetically sort the files and then feed it to the comparison command. And if we enter it, we see that there's nothing to worry about because all the lines match. So this means that all the lines that occur in this file also occur in this file. So there are no lines that are unique to this file. If we change one, say we change this to a D so the hash sum is incorrect, and we issue this command again, this line is printed. So if no lines are printed, we're happy. If lines are printed, like we can go add additional lines here. Those will all be printed, then we know we screwed up or our download screwed up or anything. So we can find these mismatches. Okay, let's go to the next one. And this is really where you can see why you shouldn't be using Windows PowerShell, because it's awful and complicated and doesn't work. And the beauty of a shell should be that it's super simple to use. Super modular, you can learn things one after another and combine them in a beautiful way and get your job done. So the command I needed like a few months ago was to recursively create hash sums of files in a directory structure. And you can do this rather easily on Bash. You can simply issue a find command, let's just say of the current directory, and specify that we only care about regular files. So if you don't know, in Unix or Unix-like systems like Linux, like the GNU project, virtually anything is considered a file. For example, directories are considered files. But we only care about regular files in this case, so like text files or MP4s or whatever. And we specify this by saying type F. Then we get to add this. This is just saying we want a null byte, so 8 zeros in a byte, to separate the individual results of this command. And this is just so that we can be sure we have something that separates the results that cannot occur in a result. And in Linux, anything can occur in a file name except a / and a null byte. Other than that, any character can occur. And of course, in a path, a / can occur. So the only thing that cannot occur in a path is a null byte. So we got to instruct find to separate its results with a null byte. And we then simply pipe this to xargs, and what xargs does is it executes a command and passes the stuff it got from its input, so its standard input, to that command. And we specify again that we want to have our results separated by null bytes, so this is what 0 does. And we also specify that we don't want the command to be executed if our input is empty. So if there are no results, we don't want it to be executed. That's what str does. And then we simply specify the command. For example, SHA-256 sum. And that's it. This is the entire command. And you can easily do this, and I'll just run this. And of course, if we have a like subdirectory and then switch to it and have a, let's just say we touch another file, go back, execute the command again, and we'll see this, and it'll just list the entire path. Of course, in this case, it's a relative path because we did a relative path search here. But this, of course, also works for absolute paths. And here's the thing why you shouldn't use Windows PowerShell. Because I asked someone to do this and then sort the output by the hash sums. And this is what I got back. If we look at this file, this here, actually there's an F missing, I think. This here is the same thing, allegedly, as this little small thing that you can just type down that's structured in a logical, straightforward, simple way. And actually what I wanted is that the output is sorted, as I said. This is what that guy sent me, like, whoa, you can do this in Windows PowerShell too. And he didn't even notice that it says like SHA-1 here instead of SHA-256, but I guess you could change this. I guess they also have SHA-2 with 256 digest size in their cryptograph cryptography class or whatever this is. So yeah, if you can just type this down as fast as you can type this down, I guess you have my full respect for that. But I don't think that's exactly practical. And of course, if you want this sorted, you can just pipe it to sort in the end and have another logical, straightforward, simple step that changes the output. And that's it. And I have no idea how you would do this in this mess. Anyway, let's move on to the next point. Let's say you did something like I just did, where I created this directory here, but you chose an awfully long name with like spaces in it and like possibly a backslash or awful stuff, and you want to switch to that directory. What you can do is simply use ** to refer to all arguments the previous command received. So let's say we make a directory which we call something like with capital letters and numbers and spaces in it, and we create this, and oh yeah, let's end it with a space because that's great. And now we want to switch to this directory. What we can do is simply say change directory to ** and it will just take this. Actually, it will take all arguments, but in this case it's only one, and add them to the cd command. And it will print the command it issued, and it will then execute the command automatically, and you will be in this directory. So that's a simple way to switch to a newly created directory, and of course in any case where you need to refer to the arguments of the previous command. The next one is useful anywhere an application uses an environment variable, because when you launch the application, you can change the environment variables to whatever you like. For example, a lot of GUI applications use locals to determine what language they should present, what currency they should use, what number format they should use, etc. And you can easily look at what your environment variables are by typing in echo $lc_, and then hitting tab 2 times. And you can see that in this case I have 9 environment variables which define what my locals are. Some of them are different because that's just how I like them. Let's just go for LC numeric. This one is, like most of them, English in Ireland, and just add UTF-8 to the end because, hey, it's UTF-8. And of course, if you launch an application, let's just say GNOME Calculator with this settings, it'll use a decimal point. So if we divide 2 by 5, we get 0.4. But what if we want like a comma for whatever reason, or we want a different currency or whatever? And we can simply change this by opening up a terminal and saying environment, new word, and then the variable we want to change, in this case LC_numeric, and then having a equals sign, and then whatever we want it to be. So let's say just DE for German, _DE for Germany. This one got to be in capital letters, and of course UTF-8, and then whatever application you want, in this case GNOME Calculator. And if we apparently don't have auto-completion here, I assume we had auto-completion, and in this instance right here, this one still works. We can use this one, and let's say do this. But if we have like different division here, we are presented a comma for a decimal point, because this one is launched with LC numeric, saying that we are in a German environment. So this one uses a comma for all its calculations. And of course you can do this for several environment variables, and you can change all of these, and you can actually change all the other environment variables too if you want to, but I think the local ones are the most useful ones to change. So let's close this, go to the next one. Actually, what you can do here if you partially typed something is you can just hit Ctrl+C, and then this command will be aborted even though it isn't actually running at this point, because you have yet to hit enter. And you can, if you are somewhere in a word, you can hit Ctrl+D and delete it, but if you hit Ctrl+D on an empty terminal, it closes it. So you can use this to close terminals in a quick way. Ctrl+D is much quicker than Alt+F4. So let's move on to the next one. It's path name expansion. Let's go to a temporary directory. Actually, quick note, you can of course have bash aliases. In this case, it's cd this thing here, and so this part is the actual alias. So tmp executes this part. I'll just copy this over here, and what this does is it switches to some directory, of course, but to which one? This is determined by what's in these backticks. And what backticks do is they execute the output of some command as a new command. So what mktemp, let's just execute this in a new terminal. What mktemp does is it creates a new temporary file, a new temporary, of course, file usually, but if you add -d as a switch, it creates a new temporary directory in the temporary folder, and it's just called tmp.something random, and it will print this result. So what this does is that it takes this result in backticks, just adds quotes for safety, and then gives this to the cd command. So this is how you can easily create a new temporary directory and instantly switch to it. Okay, but the actual thing I wanted to say is that you can have path name expansion. Now, what is path name expansion? It's a really cool way you can state the arguments to your command. Now, if you were to say something like, I don't know, copy all files to some different place on a shell that does not have path name expansion, like Unix shell do. So like if you're on Windows, for example, this is actually what the command would get. It would get a star and then some other string. And then the command would have to figure out what that star means. But if you're on a Unix-based system, like on Linux, this is actually handled by the shell. So this star is changed to whatever matches. In this case, anything that doesn't start with a period that's in the current directory matches. So if, let's say, we have a file A and we have another file AB, and we issue any command and then add a star, it will see that this is its input. So it will get this string A and the string AB because these files exist and don't start with a period. Of course, we can also include files which start with a period. Let's just touch a file .c, and again, we won't see this because it starts with a period. But if we add a period, we will see this file, and actually we'll also see the files period and period, which are folders actually, and refer to the current directory and the parent directory. And of course, we can see these directories too if we issue an LL. And of course, LL is just an alias to LS with some switches. Okay, so what we can do other than matching certain file names, and of course we can use this in paths, so you can have like a cp command and then match anything here, and then have some directory here and match like any file that starts with a B and ends in PDF. For example, this also works, But what you can do other than this is, for example, number ranges. So you can like say, let's print any number from 1 to 100, and this works. And you can of course also say we touch these files, and it will then create all these files numbered 1 through 100. And you can use string concatenation, for example. You can just say touch any file numbered 1 through 200 and add ABC to the end, and maybe add like an F to the front, and this also works. And of course you can do this with any command. And if you then want to have a directory called, let's say, dd, let's call it directory dd, created, and then move anything that starts with an F, you can just issue a move command, anything that starts with an F to dd. Oh, sorry, I typed in the star first. Of course, we have to say F star, and then we move it to dd, and all those F files are gone, and if we switch to dd, they are there. So this is how you can easily handle a lot of files with similar file names. Another thing you can do is to wait for other commands to finish. So let's say you have a long-running command. Let's just say we have a sleep command, for lack of a better example, which just sleeps for a minute. This of course is something useful you want to do, but you know that you will have to do something else afterwards, and you can't do that something else before this command finishes. So what you can do is just add an ampersand to the end, then run the command, and it will print some process ID. And you can use this process ID and wait for it. So you can just say wait for this process ID, and if and only if this finishes and succeeds. Of course, you can also just require that it finishes, but I usually say when it finishes and succeeds, then do something else, like for example echo high, where echo high is something else we want to do, and that of course does useful work, but requires this first command to finish. For example, if you have like a big copy command or install an application that takes a really long time to install or whatever, then you can use this. Of course, what you can also do is, let's say we do another sleep. I actually wanted to do a useful command, but I guess that's just distracting. So let's sleep for another minute here, and I forgot in this case to add the ampersand. What I can do is use job control. This means I press Ctrl Z, so Z if you're British, or if my pronunciation is too bad. You hit Ctrl Z, and then job control hands control back to you, the user. And what you can do is simply say, we go back to foreground, and if this ends, and of course only if it ends successfully, we echo something. In this case, we echo high, and just skip forward to when this ended, so you don't have to sit here waiting for a minute. The next thing I want to show you is to open files quickly and with the right application and from the command line. We can simply do this by issuing the command xdg-open. And I got an alias for this actually because it's so useful. It's simply O for open, and it automatically launches xdg open. So let's say we have like an image, and I'll just create an image real quick, and we'll save this to the desktop, and we'll call it untitled.png, export it. And what we can say, if we are on the desktop of course, is just, and it opens the file with the default application. And of course we can close this, and it also works with other kinds of files, not just images. Like let's just say we open file 1, and of course it opens at an Emacs, but if we change my default application to, let's say, gedit as default. Open a terminal, go to the desktop and issue the exact same command. It launches gedit this time instead of Emacs, because gedit is the new default application for this. But of course I'll change it back to Emacs real quick. So the last thing I want to show you is application specific, but it's Git. So why not include it? Because a lot of people use Git. I'll have to go to a bookmark, let's just say some Git repository. So this is a LaTeX file I used to work on, and let's open this in a terminal, and we want to do a git diff. And the default settings of Git aren't exactly great for viewing diffs. So if we issue a git diff command for, let's just say, the previous commit, we will see something like this. And if you use visual line breaking, this can get quite cumbersome to read, because you hardly have a chance of figuring out what this is, and it only gets worse if you use very long lines. If you use a line that takes up 10 lines in a terminal and only then have a new line because you only enter new lines when you start a new paragraph, this can get quite hard to read. And actually it's already hard to figure out what exactly changed in this location. What we can do is a word diff, and I got another alias for this. It's called D for diff, and I always use this one so I don't have to remember it. But what you need is git diff word diff equals color, and if we simply substitute git diff for D, so this alias will be used, we see a word diff, which is much more pleasant to look at. You can simply word by word see what changed. So we took this red part away and added this green part, and we will see this word by word. So we know exactly what changed, and we can ignore all of the white stuff. We only have to look at the white stuff if we need context. So this, I think, is very useful to know if you use Git. Thanks for watching. Okay, bye.